Okay, so we've entered all of the data into L1 and L2 from this graph, and we're going to find the quadratic function that models the data with x, the number of years past 1960, and then y is the purchasing power. So that's stat calc quad reg. We'll store this into y1. And this equation is y is equal to 0.0021 x squared minus 0.173 x plus 4.0299. My r squared for that one is 0.9784. That's a pretty good fit. Let's see what a power function would look like. Okay. Stat calc power reg. Okay. And then vars, y vars function. We'll store this into y2 so that we can see them both at the same time. So my power regression is 0.34.39 x to the power of negative 1.1087. Let's say 8. Okay. Now my r squared on this one is 0.9896. The r correlation coefficient is negative 0.994. That just means, the negative just means that the slope, it goes down. So if this is close to -1, very close to -1, that's good. Okay, it can either be close to +1 or -1, but as close as it is to either one. Let's see, I would say based on this, the power function is the better model. Function, hard to spell here, function. All right, let's see what it would look like. Wow, there's the data. That's really close. Okay, there's the quadratic, the blue, and then the red is the power. And you can see that the power model is definitely closer to the data, and our correlation coefficient, the R value, shows that to be true. So let's use the power model to predict the purchasing power of the 1983, this should be number 5, the $1983 in 2025. All right, so I'm going to disable everything else. All right, so I'm going to go to y equals, and I'm going to de-highlight the plot so that I won't see the plot lines or the plotted points anymore. And then I'm going to use just the power model, so I'm going to also de-highlight the equal sign for the quadratic model so that all I can see is the red power model. Okay, what is the purchasing power of the $1983 in 2005? Well, this is all the years past, 2055, past 1960. So I'm actually going to go ahead and write 2055 minus 1960. And I need to adjust my window. Okay, so 2055 minus 1960. Second calc value, 2055 minus 1960. I get in 2055, the purchasing value of the $1983 will be 0.22. In other words, it's 22 cents. Okay. Find when the purchasing value is 40 cents. So I need to let my Y3 be 0.40, and I'm going to calculate where those two lines intersect. Enter, enter, enter. And in year 55, it's 40 cents. Okay, so 55 plus 1950, oh crumbs, is 2005. Okay, so according to the model, 2005 is the 40 cents. So that's actually a little off from the data, but if we're using our model, that's when it would be.